The last topic for section 12.2 is something called constitutional isomers. Constitutional isomers are molecules. Could be 2 molecules, could be 3 or 4 or more. They are molecules that have the same molecular formula, but they have different structures. There's something different about the way the atoms are arranged in the molecule. So this is kind of a tricky concept. We're going to look at quite a few examples. So let's start with this molecule right here. In order to identify the constitutional isomer relationship, you have to be good at counting up the carbon atoms and counting up the hydrogen atoms in a line structure, because you need to be able to find the molecular formula of the molecule. So starting with this molecule right here, and let's say we wanted to compare it to this molecule right here. And we're going to ask ourselves, yes or no, are these two constitutional isomers? In order to do that, we first need to figure out what the molecular formula is for each of these molecules. So we've got in our first molecule 1, 2, 3, 4, 5, 6 carbons. And what I'm going to do before I count up hydrogens, I'm going to go to the second molecule and count carbons. And I'll tell you why in a second. Let's go to our second molecule. 1, 2, 3, 4, 5, 6 carbons. It also has 6 carbons. So the reason that I start with counting carbons is that if the two molecules have a different number of carbon atoms, they're not going to have the same molecular formula, and right away we know that they're not constitutional isomers. So we don't need to go through the trouble of figuring out how many hydrogens they actually have. In this case, though, they both have 6 carbons, which means that now we need to figure out how many hydrogens they have. So let's count the hydrogens next. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I know I'm really fast at that, but I've had a lot of practice, and you guys will keep practicing and you'll get fast at it too. Now let's look at our next one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. C6H14. They both have the same molecular formula. They both have the same molecular formula, but they have different structures. So yes, they are constitutional isomers. Let's take a look. What exactly am I talking about when I say that they have different structures? I'm going to erase these marks to make it easier to see them. Different structures, it's referring to how the atoms are arranged in the molecule. Ooh, I'm going too far. So for the molecule on the left, the arrangement is 1, 2, 3, 4, 5, 6 carbon atoms in a row. The molecule on the right, the arrangement is 1, 2, 3, 4, 5 carbon atoms with a branch. So those are two different structures, two different ways that the atoms are arranged. And yes, they are constitutional isomers. Let's try another comparison. Let's do this versus this. Are these constitutional isomers? Yes or no? So first thing that we are going to do is count up carbons. 1, 2, 3, 4, 5. The one on the left is C5. 1, 2, 3, 4, 5. So they both are C5. They have the same number of carbons, so that's promising. Now we need to count hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, I better write that down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. C5H10. They do not have the same molecular formula. So that means no, they are not constitutional isomers because they have different formulas. Specifically, different number of hydrogen atoms. Let's look at another example. Let's do 1, 2, 3. Let's do that versus this. Are these constitutional isomers? Yes or no? So we're going to start with counting the carbons. We've got 1, 2, 3, 4. So that's C4. Next one over, 1, 2, 3, 4. C4. So that means we need to count hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they have the same molecular formula. Does that mean that they're constitutional isomers? Not necessarily. In order to be constitutional isomers, they have to have the same molecular formula, but they also have to have different structures. So let's look at the structures of these guys. The first one is a carbon, a CH3, followed by a CH2, followed by a CH2, followed by a CH3. The last one, or the second one, is a CH3, followed by a CH2, followed by a CH2, followed by a CH3. These are both, CH3, CH2, CH2, CH3, CH3, CH2, CH2, CH3. These molecules are not constitutional isomers. They are the same molecule. They are identical. They're just drawn in different shapes. They're just drawn two different ways. When we draw a molecule, when we draw an alkane, we can draw it really any way we want as long as we have the right number of lines in there. It doesn't really make a difference, the orientation or the direction or the shape that we choose to make when we draw the molecule. It's all representing the exact same thing. So you got to be careful. You got to be careful when you're trying to decide if they're constitutional isomers or not. What you want to do is start by, number one, counting the carbons. If they have a different number of carbons, then that means right away, no, they're not constitutional isomers. They're just two different molecules. If yes, then you need to count the hydrogens. If yes, they have the same number of carbons, then count the hydrogens. If you have different number of carbon atoms, different number of hydrogen atoms, then no, they're not constitutional isomers. Not constitutional isomers. Not constitutional isomers. So count the carbons. Is there a different number of carbons? And if so, then they're not constitutional isomers. Count the hydrogen atoms. Is there a different number of hydrogen atoms? And if so, those also are not constitutional isomers. If you have the same number of carbons and hydrogens, then you need to make sure that the carbons have a different arrangement. That it's not just as simple as the molecule being drawn with a different shape, that there's something totally different about the way the carbon atoms are connected. If they have the same shape, same arrangement, same pattern, then the molecules, again, are not constitutional isomers.